So we are now going to finish up those review problems. So, so we had done, oh, actually we did number 6. We finished that.
You were doing that back class.
Yep, we're about to start 7A. Yep, we're ready for 7A. So here we go. We're on the very back of your note packet with the copy problems out of the book that say review. And we are ready for 7A that says we have a cubical die. Somebody has labeled the sides 2, 3, 3, 4, 4, and 5. So, a lot of times in math class, we do weird things with dice. So somebody has taken a regular die, and instead of having the faces be normal, 1, 2, 3, 4, 5, 6, they've got one side with a 2, 2 sides with a 3, 2 sides with a 4, and 1 side with a 5. So these are the faces on the die instead of regular. They painted on new ones. Okay? Now, it says a die is thrown twice, and the outcomes are added to give a total T. Construct a table for the probability distribution of T. Now, what that means is, this is going to be a probability distribution, and this is going to be the actual sum. I'll call it sum because I'm doing it twice. So when let's say I roll it the first time and I get a 2, and the second time I get a 3. Then my sum would be a 5. And then this is gonna be the probability of it. So I'm gonna figure out all the outcomes, and then I'll be able to figure my probabilities. Now there are several ways that you could do this, but if you think back, we actually had a problem that we did where we rolled 2 dice. Does anybody remember how we looked at that? Do you remember what we did?
You made a large graph.
Yes, we made a chart that looked like this and said, okay, the first one, before when we did it was a regular die, so it was 1, 2, 3, 4, 5, 6. Well, this one's gonna be 2, 3, 3, 4, 4, 5. There's the first one. And then the second one is going to be the same. Right? So now we're going to roll each one. So one outcome, this outcome would be I get a 2 and a 2. So my sum would be a 4. I get a 2 and a 3, a 2 and a 3, 2 and a 4, 2 and a 4, 2 and a 5. So this is the first list of outcomes. All right, now what's this list of outcomes going to be? 5, 6, 6, 7, 7, 8. So again, this is like rolling a 3 and rolling a 2. If you roll a 3 and roll a 2, you're going to get a 5. Roll a 3, you're going to get a 6. Now, a 4 and a 2 would give me a 6. 7, 7, 8, 8, 9. You're getting it. You're getting it. This is going to be the same thing, right? Because it's the same. And then a 5 would be, so there are the outcomes. How many outcomes are there? How many of these are there? No. There's 6 across and 6 down, so there's 36, right? There's 36 numbers in this list. Okay, now, how many, let's see, the smallest one is 4. How many of them are 4? How many 4s are there in our list here? 1. I'm going to go ahead and circle it, meaning I've taken that one out. You said there were 36 altogether, and 1 4. So the chance of getting a 4 is 1 over 36. There's only 1 4 in that whole list. All right? How many 5s are there in the list? 1, 2, 3, 4. Is that it?
That's it.
So to get a 5, it's 4 over 36. Now, I know that reduces, but I'm not going to, and you'll see why in a minute. I'm going to leave it unreduced for now. All right, how many 6s? 1, 2, 3, 4, 5, 6, 7, 8. Is that it? There's 8 6s, so that'd be 836. Need to make my chart a little bit bigger because I'm already at 10. All right, how many 7s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of those, so that's 1036.
Right. Is there a pattern here?
How many 8s? 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
So 836. Looks like 4 9s and 1 10. Everybody understand what I'm doing? This is called your probability distribution. This tells you the probability of each outcome. Now, the reason I didn't reduce it is, if I've done this right, this row right here should add up to what?
36.
Well, 36 over 36, right? It should add up to 1. So that's 5, 13, 23, 31, 35, 36. So we've done it right. Everything washes out. So now we can answer the questions. Whoops. I didn't ask you any questions. I just asked you to build the probability chart. So if a question were, what is the probability of you rolling an 8? You would just look here and say the probability of rolling an 8 is 836, which reduces, and so before you put it in the answer blank, you'd want to reduce it to whatever it reduces to. Right? Okay, that one's done. Now number 9. A box contains 4 blue and 3 green. Judith and Giles play a game, taking a ball out of each box without replacing it. The first player to take a green ball is the winner. Find the probability that she wins. This is kind of a hard problem. Yeah, let's cross that one out.
Let's get it.
Let's cross that one out. Let's go down to number 10A. A box contains 16. That's hurtful. I just want you to know. A box contains 16 chocolates, of which 3 are known to contain nuts. Okay? So we've got 16 total. 3 have nuts and 13 no nuts. 2 chocolates are selected at random. Find the probability that exactly 1 contains nuts. Oh, you ought to be able to do this. If we're picking, it's 2, right? If we're picking 2, then we want 1 with nuts and 1 without. Right? So what's that going to look like? How do we get 1 with nuts? 3C1, that's it, Sam. It's like blue and red marbles. It's the same thing. Spades and not spades in the card game. And 13C1. And then I'm going to divide the whole shebang because it is a probability question, isn't it? Yep, find the probability. What am I dividing by? 16C, not 1, 2. Why is it 16C2?
1 with, 1 without.
Well, I'm picking 2, and I had 16. So the total goes in the bottom. All right, so I gave all my calculators away. Would somebody calculate that for us?
13, 120. 13 over 120.
So the fraction is
39 over 120.
39 over 120. That reduces.
Yeah, 13 over 40.
13 over 40. All right, what is it decimally? for those people that like to do it decimally. 1325. 0.325. Remember, I don't care which way you do it the way that you're most comfortable. So if you like doing it fractionally, there's the answer, decimally, there's the answer. Does everybody see how that's just like the marble problem we did before? Okay.
But can you do one more other things, like, it's like,
On stack.
it's like no more than one? You know what I'm talking about?
I do. Just hang on a minute. On the back of the homework packet that I gave you.
What game?
All right, okay. All right, so we'll start our practice test next time.